All right, so I'm Delia. I'm from Nvidia. As you can see here, obviously, I don't think I see a lot of familiar faces, so I'm pleased with that. So that means I can talk about what I'm saying today, and none of you guys have heard it before. So we're going to start off basically, we're going to go over VRWorks. NVIDIA VRWorks are a set of SDKs that we have developed, and it basically helps to accelerate and to streamline your rendering pipeline for VR applications. This has already been out for about a year now, so it's old news, but if you guys haven't heard of it before, I'm going to go over the basics of it, especially on the graphics side. And then I'm going to share on NVIDIA Holodeck, a new application that we launched at GTC Europe just a couple of weeks ago. And then I'll wrap up with some successful stories of cases that I've been working on. All right, so I'll just hop right into it. So VRWorks, again, like I said, they're a bunch of SDKs. And basically, we have brought them into life, I guess you could say, is because when we think of virtual reality, we think of something that is very closely related to real life. It has to match what you see. It has to match what you hear. The physics simulation should be correct. Fire should burn like fire. Water should flow like water. And then, of course, on the capture side as well, on the CUDA acceleration for the stitching pipeline. And so VRWorks helps to bring reality and immersion into VR. And to do that, basically, we're solving the problem of simulating reality because doing so in VR is actually very difficult. And there's two reasons for that. The first one is the high performance demand due to the nature of VR headsets. Now, if you look at this, basically, it's showing you that traditionally, your monitor runs at something of this spec, and that basically means it has a performance demand of 60 MP per second. You don't really need to know what that unit means, just know that it's 60. And then when you compare that to the same specs in virtual reality, the performance demand goes up to 450. So that's about 7.5 times more of a performance demand than on a traditional PC monitor. And this demand actually is increasing with the recent release of the Microsoft MR headsets. They actually have a higher resolution over the HTC Vive and the Oculus, 60% more in resolution, actually. So if you guys are looking into developing some new, more higher resolution content, mixed reality headsets would, I think, would be a good recommendation to look at. So, but basically what this is saying is, there's a super high performance demand over PC. And more than that, the second barrier is latency. And so research has shown us that the motion to photon latency has to be less than 20 milliseconds for the human eye to feel that it's refreshing quick enough. Because, in VR, the monitor turns into your whole world. Usually, if you're just looking at a PC monitor and it lags, you don't feel like you're going to throw up right away because it's just a little portion of your world. But in VR, it's everything. So your whole world is lagging. So it cannot be more than 20 milliseconds for each frame to come in and refresh. But if you actually look at this pipeline, it's very long. And the headsets right now on the market, they all have a refresh rate of 90 hertz. What that means in time is that each frame to show on your headset takes up 11 milliseconds. So actually, of the 20 milliseconds, 11 is used up by the headset. So your whole pipeline has to be finished in less than 9. So it's extremely fast, very low latency, while driving a very high performance, and you're trying to aim for a very realistic, immersive VR experience. So that brings us basically to the VRWorks, the different SDKs that we've developed to help accelerate the pipeline, changing how pixels are calculated and how geometry is calculated. So again, like I said, there's a lot of them. We won't go over them today because we won't go over all of them today because they've been out for over a year. But if you guys have any questions, feel free to contact me. I'll have my email up at the end of this. You guys can take a photo of it, email me, come talk to me afterwards, or look online. There's lots of information online. So we'll focus on the graphics side because VR, the first thing you see is visual more than anything else. So bear with me if you're already familiar with this, because we're going to geek out for the next few slides. So we're going to dive into the head-mount display optics to show you how the challenge of pixel throughput can be addressed by carefully managing where we spend our resources and time in rendering. Now, VR headsets, they use lenses that allow your eyes to focus and to create a wide field a wide field of view for a display that is only 5 centimeters away from your face. Now, the side effect of those lenses is that they distort the underlying image. So if you can see here, what's supposed to be all 90 degrees right angles, they're twisted and warped and distorted. And so to counteract this effect, the GPU has to output a warped or pre-distorted image so that when viewed over the lens, it looks normal. Now, if you look at this, basically the GPU creates the rendered image on the right first, and then it distorts it as a final step, the necessary warp. And then if you look at what happens during the warp, you'll see that the center stays basically the same, but the edges get squashed quite a bit. So essentially, if you were showing 100 pixels here, you're probably rendering about 160 pixels here. Now keep in mind, this is work that you've already committed. You've finished rendering all 160 pixels, but you only end up showing 100. They're just getting thrown out during the distortion. And so basically, this means we're overshading the edges of this image. And you're making pixels that never make it out to the display. So the solution is basically just to render the pixels that will make it to the final warped image. And to do that, we'll need a denser sampling in the middle and a sparse sampling at the periphery. And multi-resolution shading, one of our features in VRWorks, does exactly this. It splits the image into multiple viewports. Here you can see a 3x3 grid of them. We keep the center viewport the same size, but we scale down all of the ones around the edges. This better approximates the warped image that we want to eventually generate without having to waste a bunch of pixels. And basically, because we shade fewer pixels, you shade faster. And this enables major improvements in performance without impact in image quality. Lens matte shading is a Pascal-supported refinement of multi-resolution shading. Where instead of having a tic-tac-toe board, like you saw in the previous slide, now you can define high resolution and low resolution zones, and the pixel density can vary linearly over a frame. And if you visualize this in a projection space, we're basically already rendering to a surface that very closely approximates the final lens-corrected display output. So lens matte shading and multi-resolution shading, both of these look at how can you change the rendering pipeline for pixels so that you can have more performance and less wasted performance. The key thing that makes this work is the multi-projection technology we have on Nvidia's Maxwell and Pascal architectures. Ordinarily, replicating all the scene geometry to multiple viewports would be prohibitively expensive. But with Maxwell and Pascal, we have the ability to very efficiently broadcast the geometry to multiple viewports while only running the GPU geometry pipeline once. So as long as you guys are on the 900 series or the 10 series, you're fine. All right, so everything that I just mentioned so far was on the pixel side. What about the geometry side? So as we know, virtual reality requires drawing an image for each eye. Traditional VR rendering does this in two separate geometry passes, one for the left eye and one for the right eye. And this is because even though you're looking at an image that is very similar, if you actually close your left and right eye, everything kind of shifts to the left and right a bit. So what this means is in the traditional pipeline of rendering, you actually need to create two separate geometry and do two separate passes for that. But why bother doing that? Because if we know that you're creating a VR application, we know that you're going to accommodate a headset that has a left and a right eye. It's going to be about 6.5 centimeters apart. And so we can already take this into account when we're doing our calculations. And so single pass stereo allows the GPU to render both the left and the right eye in a single geometry pass. And this saves an entire geometry pass, effectively doubling the amount of geometry you can put into a certain scene. So, especially for people who are creating lots of complicated characters with lots of ups and downs and different angles, this is something that you would look at. And finally, the last VRWorks graphics SDK is VRSLI. Now, it's different from normal SLI, where you just put multiple GPUs onto the motherboard and then it just accelerates your performance. VRSLI actually allows developers to assign a specific GPU to render for a specific eye. And with affinity support, developers can scale up to 4 GPUs and have more control over how work is split up between all the GPUs. This is an example of just some of the different titles that have used VRWorks that are more well-known, you could say. Basically, the performance that you can see it brings varies across application, and that basically depends on how much you're pushing graphics and visual and physics and all of that in your application. Personally, with the developers that I've been working with in APAC region, we've seen an increase between 20% up to 140%. So the range that you can get out of it is quite broad, so it really just depends on how much you guys are using it. And if you think about it in terms of money, it's kind of like buying a GPU and getting another one free, sort of, in terms of performance. This is another example of a partner who has been using our VRWorks. This is a Bombardier Talent 2 train, and using single pass stereo and VR SLI as well as some other Nvidia accelerations, they were able to render 155 million triangles at 90 frames per second. So this is the case for professional workflows. And as I mentioned, this is all already available from Unity in the asset store for free. It has to be compatible with the 2017.1. And so if you guys are on the older versions, you can consider to maybe just build a demo project just to test it out a little bit, see for yourself based off of the application that you want to build, whether or not you can expect to get 20%, 80%, 100% more performance. So feel free to look into this. Moving on, the next one I would like to talk about is the Nvidia holodeck. Now, for designers, reality is the bar to measure against. Professional designers need digital models to be accurate reflections of the physical. It needs to look right, it needs to have the right tolerances to see if different parts will fit, and it has to behave the way things behave in real life. And so with that, Nvidia created holodeck. If you guys haven't seen any of the videos around that, this is a quick introduction.
Go ahead and draw that mustache. Stay still. Go. That is one you can see from behind the ears, buddy.
Actually,
you go fix that. That's good.
All right. So here's the vision of what we're building. It's the design lab of the future. Artificial intelligence is ubiquitous, accelerating our design process, suggesting options based off of related designs, turning gestures and speech into models. The simulated environment is natural. Everything looks and behaves just as you would expect it to in real life, and the laws of physics are obeyed. And just like the real world, it's social and it's collaborative. Basically, you just import the CAD files, you apply the materials, and you visualize the full geometry and materials while reviewing the design collaboratively. And here are some of the different functions that you can do in holodeck. You can draw and annotate your designs, you can make accurate measurements, place your own assets, change materials, manipulate the parts. Like you saw in the video, there was a place where they exploded the car and you saw the full bill of materials. And then you can even clip through your model to see the underlying structure of your design. So we're announcing early access. If you're a designer with 3D experience who use 3ds Max or Maya, and you have a high-end VR-enabled system, you're all welcome to apply at nvidia.com/holodeck. Users admitted into early access will receive further instruction of how to get started. And my suggestion to you guys is, even if you're not right there at the moment, but you feel that this is something that you guys would like to use for whatever business case you guys have, or it's just something you would like to explore, just go apply. We have already over, I think, 2,100 applicants since about 2 weeks ago or 3 weeks ago. So if this is something that may interest you guys, just put your application in. And if you're not ready to apply, there's also an option to sign up where we can just keep you updated with product news as we release it. All right, so that brings me to my last part. So successful partners. So my job basically, I didn't explain in the beginning, which I probably should have, but basically I work with the whole VR ecosystem. So that means VR hardware developers, VR software developers, people interested in bringing VR into business solutions, and then I find these developers, work with them, and then for these VR heroes that we work with, we find business matching opportunities for them in all of APAC, which is the region that I'm particularly overseeing. So for the successful partners that I'll be talking about today, we'll cover a few of these industry verticals that I've looked at in the past year. The first one is VR arcades. Obviously, when we think about VR, it's still very synonymous to gaming, although we can see that in this past year, it has been changing a lot towards the sort of pro-consumer market over than just the pure gaming market. And it makes sense because there's not a huge market for, you know, people at home, consumers who have a headset and then will just go on Steam or go on, some platform and buy your application and play as a game. So there's very limited revenue in that at the moment. But VR arcades are a different story. So over the past 2 years, we've seen VR arcades evolve. They started off with these sort of egg-shaped chairs that gave you in my opinion, a really bad and sort of detrimental experience into VR if you've never had it before. But for the operators, it was good revenue while they were still able to attract customers because it's a quick experience, it's very little rent space, and then you can just get people in and out very quickly. But because it's a poor experience, people don't come back. And then this year, it has moved on to a lot more of sort of these setups. So you get a room, you go in, and then they use Steam as usually their platform. And then you go in, you have maybe 40 games or 60 games to choose from. And then you pay either by game or you pay for a curated list or you pay for a certain amount of time. Now, it gives the users a good experience because now they're getting good content on good hardware. But for the operators, the revenue turnaround is too slow. You see people, well, I've talked to operators at least, most of them, they're lucky if they're making revenue. Most of them are sort of just breaking even and trying to find ways to pull more customers in. So what I would like to sort of introduce here as a concept, or maybe you guys already know about it, but is sort of this multiplayer VR arcade, especially inside a shared space. So if you see here, this was at one of our events, but we brought in one of our developers' content made especially for VR arcades, and it's multiplayer. They're all standing in the same sort of 5 meter by 5 meter space, but the reason why they're not running into each other, although they're really close, is because they can see where, each, how do I put it? The virtual them and the physical them is in the right place. And so in the game, I will see someone standing next to me and physically I can touch them. They are where they're supposed to be. And so sort of this collaborative experience allows them, operators, to sort of reduce the amount of rent per person, you could say. Because now in this 5 meter by 5 meter space, they can put 4 people, 5 people, 8 people, depending on the content. So based off of this, VR Plus is one of the brands that I've been working with. Omos is the developer behind it. VR Plus is their go-to-market sort of branding. And then I would like to share their story. So basically, they opened their flagship store in Taiwan, Christmas of 2016. And since then, they have opened a total of 7 VR Plus arcades, all under their branding. They're spread across Taiwan, China, and we'll be opening another one in Philippines later this month. And you can see basically if a developer and a business model such as this can grow so quickly over just about 10 months, 11 months, then it means that there's a successful story behind it. And for us, we know the numbers and we see that it actually is a very successful story. And one of the big reasons is because of this multiplayer shared space concept. So the way they design their games basically, depending on content, it's 4 to 8 players. And they use the HTC Vive base station. Some people who are newer to VR might not know this, but the HTC Vive base stations can track as many units as they can see. And so putting 8 people in a single room using 2 base stations is very possible. It just depends on how you design your content. And they provide a curated list of games. So they only have 5 games at the moment. They release a game every quarter. And so basically, when you go there, you already kind of have an idea of what games are available. Because from their experience, a lot of the users who come in actually don't know what they want to get out of VR. It might be their first time, it might be their second time. They might have only ever seen 360 videos in VR and think that's it. And so giving them too many options actually confuses them, and they won't know what they would actually like until they actually try it. This is sort of a trailer of their first 3 titles that they released when they opened their flagship last year. It's a compilation of all 3 content, so you can tell there's differences. But you'll be able to see how they do the multiplayer and shared space. So this is the 8-player one. You can see they designed the room to actually match what they see in VR. Oh, I can't really see that, can you? But it matches basically exactly. And then these are the standing shooting games. It's 4 to 5 player. And the business model they have behind it is per game you get charged, per player per game. So every time someone walks into that room to play, it's 4 people paying for a 15-minute experience, on average about 13 USD per experience. So the turnaround for the revenue for the operator actually makes sense. Yep, so that's them. They're looking for opportunities to continue to expand in Southeast Asia. So if you guys happen to be an investor, then feel free to come talk to me. I can help bridge you guys too. Moving on from gaming, of course, there's a lot of industry verticals that I would also like to briefly just go over. VR real estate is actually a very big one. And what I'm talking about isn't the captured 360 photos and videos. What I'm talking about is rendered real estate content, because that's where I see the actual value for VR to come in. Because if today you already have a model house built, then there's no real reason for you to go and spend money and render something again. But, with VR, basically, you can start to sell, you can start to market property that hasn't been built yet. And that's, I think, the main perk of it. And being able to bring that exact same content into every single location, be it an exhibition overseas to investors, be it your different stores around the city, but everyone can get that full virtual profile of the different model homes that they could potentially be buying. And instead of physically ushering customers from model home to model home, now you can see everything, and then you can see it in detail, you can see it in immersive behavior. And for Southeast Asia, where there's many overseas buyers investing in property, this is a very efficient application of VR. In China, 51 and Conductor are 2 of the largest companies providing real estate VR services. And it's so widely used and accepted in China right now that these companies, 51 and Conductor, they deliver 2 to 3 projects a week. And so that kind of gets you to know, how much is going on in China right now. I think from my experience in Southeast Asia, it's not as prevalent yet. Maybe people are, slower to accept the technology, but it's going to come. And, if the developers in Southeast Asia don't fulfill that demand, then I foresee that, it will be the Chinese companies coming in and then fulfilling that market demand. From my experience, there's also 2 different ways to present basically the perfect virtual showroom. There's a project-based one where basically you work with a third-party developer, you give them the CAD files, and then you tell them how I want it to look, what textures, the environment, what I want it to look like. And basically they give you a very realistic rendered experience. It's very interactive. It can have lots of different customizations into it, but then you just have to work with that third party. And usually the lead time is a bit long, around a month or 2 from most of the partners I've heard from. The second one actually is a VR software tool. So basically, the VR software tool gives everyone the means to quickly and easily create rendered real estate VR experiences. There's a number of these tools already available on the market now. If you guys are interested, come talk to me. I can also give some suggestions. But basically, this gives anyone the ability to take a simple model and then create it into a VR prime estate essentially. And you don't have to be a programmer, you don't have to be a designer. Just through that software, it allows you to easily drag and drop and make everything look really nice. Like I played with it myself. It took me about half an hour to make something that looked, reasonably nice, even though I didn't know how to actually design the interiors, but the outside looks nice. So you just pull models and customize with objects, materials, and textures, sort of like what you see here. And then the last industry vertical I want to touch upon is in healthcare. I have two partners that I work with in this area that I would like to share experience on. But before I do that, I do want to also let you guys know that in healthcare for VR, there's actually a space of two different kinds. There's captured and there's rendered. Captured is really good for quickly creating lots of content because you're just recording, and then if anything, you're just doing the post-processing of stitching and putting everything together. Rendered content takes a little bit more time, but then you have a lot more flexibility of what you want to do with it. Funique, one of the developers that I work with in Taiwan, is behind this. And basically, they have custom-built cameras and custom stitching algorithms that allow you to get detailed recordings of surgeries. So medical students can get that first-person view that they usually never see when they're, shadowing a surgeon or watching from above the operation room. And their algorithms have this unique ability to magnify the video. So even a hernia repair surgery, which is usually about 3 centimeters wide in an incision, ends up being about this big in VR. And even more than that, what they do is they allow you to move closer to the video and it magnifies as it would in real life. Every time you lean close to an object, it gets bigger. And it's a very passive interaction with a 360 video, but just doing that already allows them to see much more detail and it gives you a more realistic feel of viewing. The second one is medical augmented intelligence, shown here. So basically, they provide a rendered experience. And what they do is they take CT scans and MRI scans and using cloud rendering, transform it back into a 3D model within minutes. And this is a solution that they're working with clinics and hospitals in Taiwan as well, and to bring it sort of as a VIP service to customers, because when you take an MRI and CT scan, they always give you the data, but you never look at the data because you can't understand it. If it came as a 3D model though, you would understand it. Now, based off of that same technology, they're working with a proton therapy center also located in Taiwan, because apparently Southeast Asia doesn't have any proton therapy centers, only Taiwan does. But what they do is they create a digital twin of this proton therapy center, and then using that digital twin matched with the CT and MRI scans of the patient with a cancer and with a tumor somewhere that has to be treated, they can actually simulate the calibrations of the whole proton therapy treatment center, where every unit has to be turned to get the right match of the proton therapy beam into the patient. Because usually what actually happens is they need to do physical trial and error. The patient has to lie on the bed, and then the clinicians and the technicians do a calibration based off of their expertise, and then they do an x-ray to double check whether or not it's in the right place. If it's in the wrong place, try again. And you have the actual patient lying on the bed there, probably feeling very stressed out. And so this is a way that basically VR has helped them to sort of visualize and to model. So yeah, that's another case that we're working with. And both of these partners are also looking for, hospitals and research facilities in Southeast Asia to work with. And so if this is also your area, let me know. And that basically wraps it up. I don't know if I have time for questions. I don't. Okay. But anyways, that is my email. Feel free to take a photo of it. Feel free to come find me. I'll be wandering around for a bit afterwards. Lots of business cards to give away. So yeah, feel free to come by and say hi.